Unit 1, Some Basic Concepts of Chemistry, Notes and Summary from Class 11th, Subject Chemistry, Part 1. Introduction. Chemistry defined. Chemistry is the science that studies matter, its composition, structure, properties, and changes. It deals with the infinite variety of molecules created from limited elements. Everyday relevance, whether it is curd formation from milk, rusting of iron, or the synthesis of life-saving drugs, chemistry explains the processes around us. Systemizing knowledge, by quantifying and analyzing materials, chemistry provides the basis for understanding natural phenomena and guides technological advancements. Development of chemistry, historical evolution. Early chemical practices were rooted in alchemy and ancient traditions in cultures such as India, China, and the Arab world. In ancient India, what we now call chemistry was known as Rasayan Shastra, which covered metallurgy, medicine, cosmetics, glass, and dyes. Transition to modern science. European modern chemistry emerged in the 18th century after centuries of alchemical work. The contributions from various cultures enriched the field, ultimately leading to a systematic and quantitative discipline. 1.1 Importance of chemistry. Central role in science. Chemistry bridges physics, biology, material science, and environmental studies. It explains phenomena from weather patterns to the functioning of the human brain and modern computers. Economic and societal impact. It underpins industries that produce fertilizers, drugs, polymers, and utility goods. Advances in chemistry help address major challenges such as environmental pollution and the development of new materials. Example, superconducting ceramics, optical fibers. Enhancing quality of life, methods developed by chemists led to improvements in food safety, healthcare, and technology. 1.2 Nature of matter. 1.2.1 States of matter. Solid. Particles are closely packed in an ordered arrangement, has a definite shape and volume. Liquid. Particles are close together but can move relative to one another, has a definite volume but takes the shape of its container. Gas. Particles are far apart and move freely, lacks both definite shape and volume, fully occupying the container space. Conversion. Changing temperature and pressure can convert matter from one state to another. Example, melting, boiling, condensation. 1.2.2 Classification of matter. Pure substances versus mixtures. Pure substances have fixed composition and properties, can be elements, one type of atom, or compounds, atoms of different elements chemically combined in a definite ratio. Mixtures consist of two or more pure substances in variable proportions. Homogeneous mixtures, uniform composition, example air, sugar solution. Heterogeneous mixtures, non-uniform composition, example a mixture of salt and sugar with impurities. 1.3 Properties of matter and their measurement. 1.3.1 Physical and chemical properties. Physical properties can be observed or measured without changing the substance. Example, density, melting point, color. Chemical properties describe a substance's ability to undergo chemical changes. Example, combustibility, reactivity with acids or bases. 1.3.2 Measurement of physical properties. Quantitative evaluation. Measurements in chemistry yield numerical values that include a number and corresponding unit. Example, 6 meter for length. Systematic approach. Measurements require calibration against reference standards to ensure consistency. 1.3.3 The International System of Units (SI) Overview. A standardized system established to maintain uniformity in scientific measurements globally. Table 1.1 Base physical quantities and their units. Length meter m, mass kilogram kg, time second S, electric current ampere A, thermodynamic temperature Kelvin K, amount of substance mole, luminous intensity candela CD. Table 1.2 definitions of SI base units. First, length, unit symbol meter m, short definition, defined by fixing the speed of light in vacuum at 29 crore 97 lakh 92,458 meter per second using the cesium standard for the second. Next, mass, unit kilogram kg, short definition, defined by fixing Planck's constant at 6.62607015 into 10 to the power minus 34 joule second, with the meter and second defined via C and the cesium frequency. Time second S, short definition, defined by fixing the cesium 133 atoms hyperfine transition frequency at 91926317770 Hz. Electric current ampere A, defined by fixing the elementary charge at 1.6021766634 into 10 to the power minus 19 coulomb, where 1 coulomb is equals to 1 ampere second. Thermodynamic temperature Kelvin K, defined by fixing the Boltzmann constant at 1.380649 into 10 to the power minus 23 joule per Kelvin. Amount of substance mole contains exactly 6.022140076 into 10 to the power 23 specified elementary entities Avogadro's number. Next, luminous intensity candela CD, defined by fixing the luminous efficacy of monochromatic radiation 540 into 10 to the power 12 Hz at 683 lumen per watt. Next, table 1.3 prefixes used in the SI system. So friends, in this table we have written powers with minus symbol, 10 to the power minus 1 deci D, 10 to the power minus 2 centi C, 10 to the power minus 3 milli M. So you can note it down: deci, centi, milli, micro, nano, pico, femto, atto, zepto, yocto. So I have learned it like this. Then power decreases like this: 1, 2, minus 3, then add minus 3, minus 6, then minus 3, minus 9. So we have decreased minus 3 powers up to yocto. In this table, we have written the prefix in increasing order: deca, hecto, kilo, mega, giga, tera, peta, exa, zeta, iota. So the increasing order of the power is 1, 2, 3. Then similarly, like previous one, we have to add plus 3. So plus 3, 6, then plus 3, 9, plus 3, 12, plus 3, 15, up to 24. So you can learn it like this. So you can pause the video and note down the previous table and this one. 1.3.4 Mass and weight. Mass, a measure of the amount of matter in a substance. It is an intrinsic property and remains constant regardless of location. Weight, the force exerted by gravity on that mass, dependent on the gravitational field strength and thus varies with location. 1.3.5 Volume. Definition: volume measures the amount of space occupied by an object. Units: SI unit cubic meter, meter cube. In laboratories, cubic centimeters, centimeter cube. Decimeters cubed, decimeter cube. Commonly 1 liter is equals to 1000 centimeter cube. Measurement devices. Common instruments include graduated cylinders, pipettes, burettes, and volumetric flasks. 1.3.6 Density concept. Density is the mass per unit volume. Density is equals to mass divided by volume. Units: SI, kg per meter cube. In chemistry, often expressed in gram per centimeter cube. Significance: indicates how compactly the particles in a substance are packed. 1.3.7 Temperature. Scales: Celsius, degree Celsius, commonly used in everyday measurements. Water freezes at 0 degree Celsius and boils at 100 degree Celsius. Fahrenheit, degree Fahrenheit, popular in some regions. Kelvin K, SI unit, absolute temperature scale. 0 Kelvin is absolute zero. Conversion relationships: degree Celsius to Kelvin. Kelvin is equals to degree Celsius plus 273.15. Degree Celsius to degree Fahrenheit and vice versa. Standard formulas apply. So friends, using this formula, you can convert degree Celsius to Kelvin or Kelvin to degree Celsius. 1.4 Uncertainty in measurement. Measurement uncertainty. Every experimental measurement has inherent uncertainty due to instrument precision and measurement technique. Results are represented with a specific number of significant figures reflecting both measured and estimated digits. 1.4.1 Scientific notation. Purpose: to handle extremely large or small numbers, example Avogadro's number or the mass of an atom, efficiently by expressing them in the form n multiplied by 10 to the power n. Operations: multiplication and division. Multiply, divide the digit terms and add subtracts the exponents. Addition and subtraction. Convert numbers so they have the same exponent before combining the digit terms. So friends, as you can see here, 5.6 into 10 to the power 5 multiplied by 6.9 into 10 to the power 8. So the base is same, and when it is in multiplication form, you can add the powers like this: 10 to the power 5 plus 8, and we get 5.6 multiplied by 6.9. Then power is added into 10 to the power 13, and you can write the number like this. Similarly, if the powers are in minus form like this, minus 2, minus 6, then we add the powers: minus 2 plus minus 6. So minus 2 minus 6, it becomes minus 8. And when it is in division form, then powers are subtracted, like minus 3 minus 4. It becomes minus 7. So here, as you can see, we have to add these two numbers, but powers are different: 10 to the power 4 and 10 to the power 3. So we have to make the exponents equal. So we have converted 8.95 to 0.895 multiplied by 10.4. So the powers are same now. So now we can add 6.65 in 0.895, as you can see here. And in case of subtraction also, as you can see, the powers are different, so we make them same: 10 to the power minus 2, 10 to the power minus 2. When the exponents are same, then we can subtract 2.5 and 0.48. So this is multiplication and division and addition and subtraction via examples. 1.4.2 Significant figures. Definition: the digits in a number that contribute to its precision. Certain digits plus one uncertain digit. Rules: non-zero digits always significant. Leading zeros not significant. They only set the decimal point. Captive zeros always significant between non-zero digits. Trailing zeros significant only if there is a decimal point. Operations: addition, subtraction. The result is limited to the least number of decimal places of any number in the operation. Multiplication, division. The result is reported with the same number of significant figures as the factor with the fewest significant figures. 1.4.3 Dimensional analysis concept: a method for converting units using conversion factors which are equal to 1, ensuring that the final answer has the desired units. Application: convert between unit systems, example inches to centimeters, liters to cubic meters, by multiplying by appropriate conversion factors. 1.5 Laws of chemical combinations. 1.5.1 Law of conservation of mass. Statement: in any physical or chemical process, mass is neither created nor destroyed. The total mass of reactants equals the total mass of products. 1.5.2 Law of definite proportions. Statement: a given compound always contains the same elements in exactly the same proportions by mass, regardless of the source. 1.5.3 Law of multiple proportions. Statement: when two elements form more than one compound, the masses of one element that combine with the fixed mass of the other are in simple whole number ratios. 1.5.4 Gay-Lussac's law of gaseous volumes. Observation: when gases react, if temperature and pressure are constant, their volumes combine in simple ratios. 1.5.5 Avogadro's law principle: equal volumes of all gases at the same temperature and pressure contain an equal number of molecules, distinguishing between atoms and molecules. 1.6 Dalton's atomic theory: key postulates: matter is made of indivisible particles, atoms. All atoms of a given element are identical in mass and properties. Different elements have different kinds of atoms. Compounds formed by atoms combining in fixed whole number ratios. Chemical reactions are rearrangements of atoms. Atoms are neither created nor destroyed. 1.7 Atomic and molecular masses. 1.7.1 Atomic mass. Definition: the mass of an individual atom, extremely tiny and generally expressed in atomic mass units AMU. 1.7.2 Average atomic mass concept: the weighted average of the masses of all isotopes of an element based on natural abundance. 1.7.3 Molecular mass. Definition: the sum of the atomic masses of all atoms in a molecule, example water, H2O, has a molecular mass that is the sum of two hydrogen atoms and one oxygen atom. 1.7.4 Formula mass usage: for ionic compounds or non-discrete molecules, the formula mass is calculated by summing the atomic masses as represented in the chemical formula, example NaCl, sodium chloride. 1.8 Mole concept and molar masses. Mole definition: a mole represents a fixed number 6.022 multiplied by 10 to the power 23 Avogadro's number of elementary entities, atoms, molecules, etc., and serves as a bridge between the atomic scale and macroscopic quantities. Molar mass: the mass of 1 mole of a substance, numerically equal in grams to the substance molecular or formula mass in atomic mass units. 1.9 Percentage composition. Mass percent: the mass percentage of an element in a compound is calculated by dividing the mass of the element present in 1 mole of the compound by the molar mass of the compound and then multiplying by 100. 1.9.1 Empirical formula for molecular formula. Empirical formula represents the simplest whole number ratio of elements in a compound. Determination: use the mass percentages to find the moles of each element in a given sample, often taken as 100 gram. Divide by the smallest number of moles to obtain the simplest ratio. Relating to molecular formula: if the molar mass of the compound is known, the empirical formula is multiplied by the appropriate factor to obtain the actual molecular formula. 1.10 Stoichiometry and stoichiometric calculations. Definition: stoichiometry deals with calculating the relative quantities of reactants and products in a chemical reaction using the balanced chemical equation. 1.10.1 Limiting reagent concept. In reactions with non-stoichiometric amounts of reactants, the limiting reagent is the reactant that is completely consumed first, thereby limiting the amount of product formed. 1.10.2 Reactions in solutions. Concentration measurements. Different ways to express the concentration of a solution include: first, mass percent, ratio of the mass of the solute to the mass of the solution multiplied by 100. Second, mole fraction, ratio of the number of moles of a component to the total number of moles in the solution. Third, molarity, number of moles of solute per liter of solution. Fourth, molality, number of moles of solute per kilogram of solvent. So friends, we represent molarity with capital M and molality with small m. Balancing chemical equations. A balanced equation ensures that the number of atoms of every element is the same on each side, in accordance with the law of conservation of mass. Stoichiometric coefficients convey the molar ratios needed to perform stoichiometric calculations for mass, moles, volume, and number of particles. Finally, summary. Foundational concepts. Chemistry is the study of matter in its innumerable forms and transformations, paving the way for understanding natural and synthetic processes. Historical perspective. The field has evolved from ancient alchemical traditions to a systematic quantitative science built on experimental laws and theories. Measurement and units, proper measurement and the use of SI units are central to uniform, precise, and accurate scientific work. Tools such as dimensional analysis, scientific notation, and significant figures ensure the integrity and reproducibility of experimental results. Matter and its classification. Matter exists in different physical states, solid, liquid, gas, and can be classified as pure substances, elements and compounds or mixtures, homogeneous and heterogeneous. Chemical laws and theories. Empirical laws, conservation of mass, definite and multiple proportion, Gay-Lussac's, Avogadro's, and Dalton's atomic theory form the backbone of modern chemical understanding. Quantitative chemistry. Concepts like atomic molecular mass, the mole, and molar mass link the microscopic world to macroscopically measurable quantities. Stoichiometry, including limiting reagent analysis and concentration calculations, allows us to predict and control the outcomes of chemical reactions. So friends, our summary is complete. We will do question answers of this chapter in a separate video like this. So I am working on it. We have completed notes and summary from Unit 1, some basic concepts of chemistry. I have tried to compile and cover every topic in the unit. I hope you like it. If you like the video, kindly like it and share it with your friends. Also subscribe to my channel. You can support me with channel membership and super thanks. We will meet in the next video. Thank you for watching.